All right, so chapter 6, okay, we're talking about functions, we're talking about slope, we're talking about equations of a line and graphs and things like that. And so what we're going to talk about are the big ideas. There's really only two big ideas here in this whole chapter. The first one is the graph of a linear function is a non-vertical straight line with a constant slope. So if we take a look at a non-vertical straight line, that's a linear function. A vertical line, so the one that goes straight up and down, why is that not included in this? What's so special about a vertical line? Do you remember? Okay, the slope is undefined, right? And it is not a what? Function, right? It's not a function. So we can't figure out the slope. It's not a function, so we don't really deal a lot with vertical lines, okay? So this is a function because every x value just has one y value. And we can determine the slope of a line really easily. So the slope of this line is equal to the difference in height between any 2 points, that is the change in y, right? Delta y, divided by the change in horizontal distance between any 2 points on the line. That's delta x. So slope is m, and it's delta y, or the change in y, over the change in x. That can also be written as y2 minus y1 over x2 minus x1. Very important stuff there. Find the slope, okay? Count up, write that number down. Count over from point to point, write that number down, divide the two, slope, done. Okay? The slope will also have units of the vertical axis divided by the units of the horizontal axis. So your slope, if we're dealing with an actual problem, the rate will be, in this case, a over b. So your slope will be some number value, and the units will be a over b, because we're taking these units and dividing by these units. Okay? All right, so what about parallel lines? Parallel lines are lines that what? What are parallel lines? They what? Never intersect. Okay, so they have the same what? Slope. The same slope, yeah. Parallel lines have exactly the same slope. Good. Same slope. And perpendicular lines, well, perpendicular lines would be two lines that what? Very good. Oh, some of you guys are on the ball here. That intersect to form a right angle. And so what do we know about the slopes of perpendicular lines? That's a little bit different, right? So if the slope of this line right here, line number 1, okay, if that slope is, let's say it's 1/2, what is the slope of line 2 if we know that it is perpendicular? Okay, minus, okay, so it's the opposite sign. This is a positive, so this must be a negative, good. And then what do we have to do? Okay, but why? What do we do? What do we do with the first slope? We change the sign, and then we do what? Take the, okay, reverse, or it's actually reciprocal, right? So you change the top and the bottom numbers. Okay, so this is negative 2 over 1, or simplify, we would just say negative 2. Okay? So yes, you had the right answer. I just want to know if you knew why you had that. Okay, good. Any questions? That's big idea number 1. We talked about slopes. Big idea number 2 is we talked about equations of a line. Okay? And we talked about 4 different equations. I only mentioned 3 here, but the 4th equation was mentioned, but they didn't make a big deal of it. So I'll get to that when we get through these. But so an equation of a linear function can be identified in 3 different forms here, or actually 4 different forms. When we talk about this one is the standard form, right? Remember that one? Standard form. That one was in your notes from yesterday. Okay, so I'll get to that one when we get there. But this one is the slope-intercept form, and it's y equals mx plus b, where m is the slope of the line, b is the y-intercept. It's the y value of the y-intercept point. So if you know the slope and the intercept, you can just plug those values in, and all of a sudden, boom, you have an equation for all of the points on the line. All of the points. How the x values and the y values for every point are related to each other. The second type of equation is the point-slope form. Okay, so point-slope. Well, the point is represented by this is the x value of the point. So here's point x1 and y1. There's the x value for the point. There's the y value for the point. Okay? And so there's the slope right here. And so you can always write an equation for the line if you're given the point, or one point at least, and a slope. Okay, thirdly, general form. So a lot of times we'll show lines in general form. Maybe not quite as useful as the other two here, really. But a is a whole number, so it has to be positive. Can't be 0. Wait, yes, technically, yeah, it can be 0 actually. It's a whole number. Now, if a is 0, that means we don't have an x value. That means it's y equals something. That's a horizontal line. So a actually can be 0. B can be any integer, positive or negative whole numbers. And so can C. All right? So in order to be in this form, we have to have a is a whole number, b and c must be integers. They must be in this order, and we must have equals 0 on the other side. Okay? So this is not in general form. This is in general form, technically. Now, would you say, well, Mr. Master, we don't have a y value there? Well, we actually do, but the b value is what? It's 0, yeah. You see? So this is in standard form, but when you have 0y, this is okay too. Okay, so just so you know, 0 actually can be, 0 can be a, 0 can be a coefficient. All right, and standard form is very similar. Ax plus by equals c. So we have the constant on the other side, okay, of the equation, and that's standard form. Okay, questions to that? All right. Those are the big ideas. That's the review for Chapter 6, and I will talk about some skills here as well next.